Alright, so we've dealt with the transfer learning and feature extraction. So now it is time to take a look at fine-tuning. Here I have a summary of the best results of what we've seen now. Just without transfer learning, 100 epochs, we had 85% without overfitting. Then we used transfer learning on ResNet 50, and there we had the best result, ResNet 50 plus dropout, using method 1. Remember, method 1 here was the method with 2 layers, where basically we extract the features from the base and put these features in an array or a matrix, and then feed that array directly into the fully connected layer. Yeah? 71.1%, 100 epochs, but there is some overfitting, not early, but you know, from layer 40 onwards, or epoch 40 onwards. And then we had VGG 16 plus data augmentation, where we used method 2 using 4 layers. That gave us an accuracy of 90% without any overfitting. So what we're going to do now is we're going to see the effect of fine-tuning on VGG 16, ResNet 50, and we will do that with data augmentation. So we will use method 2 here, yeah, data augmentation, and we will run 100 epochs. Now this takes a very long time because there's a lot of parameters to be trained. Yeah, we'll not sit out until the full 100 epochs are finished. But you know, after 10, 20 epochs, we will be able to give a sort of tendency of where this is going. So what is fine-tuning now? Well, remember we had our pictures, 150 by 150 by 3. We channeled them through a convolutional base, and what we did in method 2 here is that we froze the weights of that base. Because you're going to iterate through the 4 layers, you don't want the algorithm to update the weights of your convolutional base. The whole idea of this convolutional base is just making life easier and use the weights that have been trained, for example, on ImageNet. Yeah? Well, fine-tuning complements feature extraction, and basically what you do is you're gonna unfreeze some of the layers of your convolutional base. Yeah? For example, you could keep the first 3 convolutional layers, and you could unfreeze the 4th one. So the 4th one becomes part of your training loop and will adjust the weights. Yeah? Of course, the further you go to the right, the more abstract the features are. Remember, in the beginning, you're just recognizing edges and stuff like that, whereas the further or the deeper you go, you will actually look at ears, eyes, or even the head of a cat or a dog. Yeah? So we're going to do one coding exercise. As I said, we're not going to finish it because it takes way too long, but it should give us an idea of where this is going. So let's take a look at this.